Welcome to the next session, my dear friends. In the previous session, we were discussing the major air pollutants present in the air. Okay, so we have discussed up to carbon monoxide, which causes asphyxia because of the combining that carbon monoxide will combine with the hemoglobin and creates and forms carboxyhemoglobin. And next is oxides of sulfur, SOx. Oxides of sulfur. So oxides of sulfur, generally this is the important pollutant present in the cities. Okay, so the main pollutant present in cities. Generally, this is evolved from the thermal power plants. Okay, so these sulfur dioxide comes out of the combustion of fuels, especially where we use coal. From there, this sulfur dioxide will come. So whatever the sulfur content that is present, okay, the unburnt sulfur content present in the or else whatever the sulfur it is being consumed during the burning. So we have already one question we did. So in coal, some 1% to 4%, starting from 1% to 4%, sulfur will be present. In that sulfur, what is the portion of sulfur is consumed for the combustion purpose? That sulfur will react with oxygen and supports the combustion. So after the combustion part is over, the sulfur and oxygen will combinedly form sulfur oxides. Okay, sulfur oxides. So these sulfur oxides are dangerous to the environment. So they are responsible for acid rains also. This SOx will react with water and forms sulfuric acid. So that sulfuric acid in turn causes acid rain, and because of that acid rains, crop yield will reduce, the fertility of the land will reduce. So it also causes some kind of skin diseases, so for human beings also. So that is why SOx is an important pollutant which needs to be restricted. So if the SOx is more than the prescribed limit, so it causes laxative effect. Okay, it causes laxative effect and also irritation to the respiratory mucous membrane. Okay, it causes irritation to respiratory system, and also it causes laxative effect. It also causes laxative effect. So also damages crop yield. It also damages crop yield, plant growth, and monuments also because of this sulfur dioxide presence. So sulfur dioxide or sulfur trioxide, because of this presence, even the monuments, marble structures like Taj Mahal and all, so they will lose its color. So that is also another problem of SO2 emission, and also it damages the monuments. So So this is the problem associated with the sulfur dioxide. So it comes out of the combustion of the fuel. So it comes out of the combustion, comes out due to combustion of fuels, especially coal. So thermal power plants are the prime sources of this sulfur dioxide, oxides of sulfur. Okay, so thermal power plants they produce this SOx. And how to measure this? We use West and Gaek method. So West and Gaek method is used to determine SOx. Okay, so this is the most important, most predominant pollutant present in the cities. That is very, very important point. After this, next major pollutant is oxides of nitrogen. So there are many oxides of nitrogen are there. There are many oxides are there. That means when nitrogen reacts with oxygen, it forms various compounds. But we don't treat all of them as pollutants. We treat only few of them are pollutants. So let us see oxides of nitrogen. So when nitrogen reacts with oxygen, it forms various compounds. So such as N2O, NO, NO2, NO3, N2O3 and N2O4 and N2O5. So these are the 7 compounds that generally forms when oxygen and nitrogen reacts. But among these two, one is nitric oxide. This is nitric oxide and nitrogen dioxide. So these two are considered as pollutants. So nitric oxide and nitrogen dioxide, these two are considered as pollutants. And all the photochemical reactions, majority of the secondary pollutants which comes out of the photochemical reactions of these nitrogenous compounds with different kinds of hydrocarbons. Okay, so for example, this NO2 taking the energy from the sunlight. So this is photon energy from the photon. So it forms energized NO2. So this is energized NO2. So this energized NO2 they will form NO and a nascent oxygen. This nascent oxygen it may react with O2 and forms O3 in the environment, which is a pollutant in the environment, or else again this O3 go back and react with this nitric oxide and forms again NO2 plus again a nascent oxygen will get released out of it. So these are the reactions. So both NO2 and also again here O2 will come. So balance this reaction, we will get it. So 2 to 4. So 3 plus 1, 4. Okay. So O2 will come. So these NO or NO2 both are pollutants. So if hydrocarbons are present, so with these, when NO2 is present in the environment, parallelly hydrocarbons are also present and heat energy is present. Okay, if propane is present, so then what it will form? PPN, peroxy propanol nitrate. If a butane is present, so if our acetylene is present, so whatever the hydrocarbon is present, so it will form peroxy compounds of it and creates a secondary pollutant when heat energy is available. So these are all photochemical oxidation of this nitrogenous compound as well as one hydrocarbon present in the environment as a pollutant. This again they are forming secondary pollutants. So that is why majority of the secondary pollutants are coming out of this nitrogenous pollutants only. And here after SO2 and SO3, so after SOx, the second most predominant pollutant in cities is NOx. So after SOx, NOx will be the secondary most important pollutant, most predominant existing pollutant in cities. And here this is also it also causes acid rains. This NOx, NO2 or NO3 reacts with rainwater and forms nitric acid, HNO3 nitric acid. So this acid rain, the same effect of acid rain because of the SOx, the same effect will be there here also. So it also reduces the plant yield, fertility of the soil, and also causes some kind of skin diseases. So all these things will come when NOx is also present. So this HNO3 again reduces the fertility of the soil. So next pollutant is, okay, we need to estimate this. How do we estimate this? We estimate NOx using Jacob-Richter method. So we estimate it. It is estimated using Jacob we estimated with this method. Okay, it is estimated with this method. So this is about the oxides of nitrogen, oxides of nitrogen. So if it is present in excess, this also damages the respiratory components. Okay, so this NOx, it will damage the respiratory tract. So this is a part of respiratory tract. So it damages this alveoli. Okay. So in our respiratory component which is present inside the lung. So this is like a leaf. See, in lungs there will be a leaf kind of structure will be there. So this leaf kind of structure is called alveoli. So it generally this is a porous membrane. So whenever we respirate, the air will go into this alveoli. It expands and contracts. It stores the air. So if you smoke cigarettes and all, this porous spaces will get clogged with that fine material, smoke which is coming into your lungs. Similarly, this NOx will also having the same kind of effect. So it will clog these porous spaces which does not allow the air to enter. So the expansive nature and contractive nature of this alveoli will get disturbed. It will reduces. So because of which you face some kind of respiratory problems and damages occur to the lungs. So that is about the nitrogen compounds, NOx. And after this nitrogenous compounds, they are hydrocarbons. So hydrocarbons, there are various types of hydrocarbons, among which aldehydes. So aldehydes are the predominant hydrocarbons which present as a pollutants. Next is hydrocarbons. So the effect of this formaldehyde. So major hydrocarbon is formaldehyde, which present in the nature as a pollutant. So it is an irritating compound. Okay. It irritates the eye, respiratory irritation. So the major hydrocarbon present is formaldehyde, which causes, so it is an irritant. It causes irritation to eyes and a nasal irritation, etc. Nasal irritation, etc. So we use, and also too much concentration may cause lung cancer. It may cause lung cancer. So it is estimated using gas chromatography. It is estimated using gas chromatography. Okay. This is about the hydrocarbons. These are the major pollutants present in the environment. And there are some kind of greenhouse gases. So the global impact of air pollution. What is the global impact of the air pollution? So what is the effect of this air pollution throughout the world? So the global impact. See, whenever we release any kind of pollutant, so that pollutant will present inside the environment which is surrounded by the earth, and this environment is having a structure. This environment is nothing but atmosphere. So this atmosphere will have a structure on the earth. Okay, what is the structure? First of all, let us see what is the composition and the structure of the atmosphere. So composition and structure of atmosphere. See, if you look at atmosphere, so there are different layers. So when you look at earth, so this is earth, and it is having a surrounded some kilometers. We are having this atmosphere is extended. So this is atmosphere. So this atmosphere contains different layers. This atmosphere contains different layers. So if this is the earth, okay, so this is the atmosphere. So this atmosphere contains different layers with some altitude. So the layers are separated by a adiabatic layers, so which does not having any transfer of heat takes place. Okay, so first layer is troposphere. So this layer is nothing but troposphere. Troposphere. So it ranges from 0 to 11 kilometers, in which actually our flights will travel. So we get oxygen, we get everything in this troposphere only. So our life depends on this troposphere only. And the temperature ranges from, at the surface, it ranges approximately, I am taking 15 degrees. So at the surface, the temperature will be at 15 degrees, and at the boundary, so at the boundary it ranges to minus 56 degree. So very cold, minus 56 degrees centigrade. So that means the temperature, if you take a scale of temperature with altitude, okay, temperature on x-axis, and altitude on y-axis. So this is 0 to 11. So if this is 15 degree, so it is decreasing to minus 56. So likewise the temperature will decreases when it is moving upward. Okay, 11th kilometer, up to 11th kilometer. From 11th kilometer to 50th kilometer, 11th to 50th kilometer we call it as stratoscope. So 11 to 50, 11 to 50, so 11 to 50th kilometer, so it is stratosphere, it is stratosphere. Here the temperature from minus 56, it increases to 2 degrees centigrade. So again the temperature will increases to 2 degrees centigrade in the stratosphere. This is stratosphere. And this is troposphere. And from 50 to 85 kilometer, that is mesosphere. 50 to 85 kilometer, 85 kilometer, that is mesosphere. Here temperature increases to 96 degrees. So here again the temperature decreases. The temperature decreases to minus 92 degrees. Okay, temperature decreases to minus 92 degrees. So again the temperature will decreases in mesosphere. So topmost is ionosphere. So this is 85 to the maximum extent up to environment is present, that is 500 kilometer. Okay, thermosphere or ionosphere. Thermosphere or ionosphere. So 85 to 500 kilometer, we call this as, so temperature increases, thermosphere or ionosphere. Thermosphere or ionosphere. So these are the composition and structure. This is a structure. So what is the composition? What is the composition of the atmosphere? So this is the structure of the atmosphere. So the composition. So it contains major compound present in the troposphere. We generally talk about the troposphere. So rest of the layers we don't study much. If you take the troposphere, in this troposphere, the air contains 78% of nitrogen. Okay, so here in troposphere, air contains nitrogen as N2, 78%. After nitrogen, the major compound that is present is oxygen, O2. Oxygen 21%. Approximate values. These are all approximate values. And argon 1%. After this, argon, inert gas. Argon 1%. Ag is argon. Argon is 1%. And carbon dioxide 0.03%. So rest of the gases are in traces. Okay. So rest of them are in traces. So most of them are inert. So major composition, major compounds that are present in the air is nitrogen and oxygen. Nitrogen and oxygen. So this is the composition of air and the structure of the air. And if you look at the global warming, so the major effect of the air pollution is global warming also. So you might have heard in news again and again. So the icebergs are melting, the mean sea level is rising. So the global temperature is increasing year by year. It is increasing by 1 degree centigrade or 2 degrees centigrade. So this is all are the effects of the global warming. So why this global warming is happening? Because of greenhouse gases. Because of the presence of the greenhouse gases. What are the greenhouse gases? What they do? Generally, greenhouse gases are having more amount of heat absorption capacity. So when a sunlight ray is hitting the Earth's surface, it will reflect back. So generally, normal gases will leave that ray out of the environment so that the temperature of the Earth does not get affected with those gases. But if some gases like CO2, methane, so these kind of gases will not allow the reflected ray to go out of this environment. So they will store that energy which is reflecting back. So that means what they are doing, they are not leaving the energy out of the environment, they are absorbing themselves, because of which they are getting warmer, because of which the environment is getting warmer, the atmosphere is getting warmer, and we are facing the warmth. So that is the concept of the greenhouse effect. So the greenhouse gases effect. So because of which the global warming is taking place, because of which the global warming is taking place. Okay, so because of which the global warming is taking place. So what are the different greenhouse gases? So there are many greenhouse gases are there, many. These days, industries are producing lot of greenhouse gases, but greenhouse gas will have two things to understand. One is its quantity, and another thing is its residence time. That means how much time it is present. That means what is the shell life. So for example, if you see, you may know or not know, I don't know, water vapor is also a greenhouse gas. Water vapor is also a greenhouse gas. But the water vapors, the shell life is only 7 days. So that is why, though the quantity of water vapor present on the earth's surface is very huge, every day lot of oceans, sea, rivers, majority of the water is getting evaporated. So if you see, if you are residing near a shore of a sea or a river, in the daytime you will feel more warmth because of that vapors which are entering onto the land mass. So they won't allow the reflected ray to go out. That is why the coastal people will face more sweat as well as more warmth. Similarly, during the night, so they feel more cold because the radiation, the cool radiation also not going back, heater radiation also not going back. So because of which the coastal people will face more amount of warmth in the sun during daytime, and similarly coldness, where they feel very cold during the night. This is the reason why, because the water vapor is also act like a greenhouse gas. Okay, many of us don't know this. So there are many kinds of greenhouse gases, but water vapor is not a critical thing for us because it hardly stays 7 days in the environment. After that it will condenses and comes back onto the ocean or sea again. So that is why the water vapor is not a big critical problem for us. Whereas polythene, so these kind of things will have a shell life of 100 years, 1000 years. So till that time they will sustain in that environment. That is the big problem for us. So that is why, though the quantity is lesser, if its lifetime is more, then it is also a critical greenhouse gas. Based on that, we classify the major greenhouse gases. Okay, so the major CO2, first and foremost, very important is CO2, CH4, CO2, CH4 and nitrous oxide, N2O, nitrous oxide and chlorofluorocarbon. So majorly carbon dioxide, approximately it takes a percentage of 57% greenhouse gas from carbon dioxide, and methane approximately 12%. If you take this as 100%, the proportions I am telling. So nitrous oxide about 6% and CFCs, chlorofluorocarbons, it is approximately 25%. This is the proportion of the major greenhouse gases present in the environment. And these chlorofluorocarbons are also responsible for the depletion of ozone layer. So these chlorofluorocarbons are also responsible for the depletion of the ozone layer also. So because of which the ultraviolet rays enters directly onto the Earth's surface, because ozone layer will resist, it will not allow the ultraviolet radiation to enter onto the Earth. Only visible radiation will come. Okay, so visible rays will come, so the ozone layer will reflect the ultraviolet radiation. But if this chlorofluorocarbons, that means CFCl4, okay, so CFCl4, so what they do, this chlorine, whatever the chlorine present in this chlorofluorocarbon, it reacts with ozone and forms ClO. Okay, it forms ClO such that the ozone layer is depleted and converted into ClO and O2. So whatever the chlorine present in this, it go and react with O3 and it forms a ClO and O2. So now this has got depleted. So the ozone has got depleted. So that is generally these is chlorofluorocarbons. are also called freons. This is also called freon. So these freons are responsible for the ozone layer depletions, which comes generally, these are the propellants. These are the propellants from refrigerators. Okay. So generally, majorly the refrigerators, air coolers, so they generally very old refrigerators and all. These days we have eradicated this. We have overcome this problem by modifying this without using chlorine, fluorocarbons. So we use hydrofluorocarbons instead of chlorofluorocarbons. Now for refrigeration purpose we are using hydrofluorocarbons. So we are using hydrofluorocarbons to prevent this chlorofluorocarbon emissions and all. Okay. So this is all about the global impact of the air pollution. This is all about the global impact of the air pollution. Now, whenever we generate any kind of pollutant, so we need to dispose it safely out of the environment. Out of the environment means we always think that out of the troposphere at least, so that it will not come back, because every layer is separated by isothermal layers. So the air parcel or the pollution parcel, once it goes out of the troposphere, it will not come back into the troposphere again, because the temperature will not permit for that. Okay. So always whatever the pollutant we generate, so at least we need to send that pollutant out of the troposphere. That is our task. So how to do that? So for that we need to understand the lapse rate of the environment and the air parcel. So there is a term called lapse rate. So what is meant by the lapse rate? What is meant by lapse rate? Lapse rate is nothing but change in temperature with change in altitude. So change in temperature with change in altitude is nothing but lapse rate. It is nothing but lapse rate. So I have already shown you the troposphere structure. In that, when we are moving up, the temperature is decreasing. Okay. So from 15 degrees to minus 56 degree. So that means, so whenever we move up, the temperature will reduces. That is clear for us. So that means there is some lapse is there. There is some reduction of the temperature is there. That is nothing but lapse rate. Again, this lapse rate is of two types. One is environmental lapse rate. Another thing is adiabatic lapse rate. First one is environmental lapse rate and another thing is adiabatic lapse rate. So what is meant by ELR? So when we need to see two things here parallelly. One is environment, another thing is pollution parcel. So generally we leave this pollution parcel from the stacks. So if you see any industry, every industry will have a big long shaft. So vertical shaft will be there like this. So from this shaft, they releases the pollutant into the nature, into the environment. So this is nothing but this arrangement is called stack. So from this stack, we are emitting this because relatively we keep it at a greater height so that it will not interfere the normal altitude where we reside. So we have to lift it up to a greater height such that it does not come back into the residential areas. So that is why we construct this stack. So where you are emitting this pollutant into the nature or environment, where we are emitting this pollutant into the nature. So from this point, So now it is interacting with the environment. So now this is the pollution parcel, this is the environmental parcel. So environment, this is pollution parcel. Simple logic here, only one logic we need to remember. Always lighter one, warmer one will be lighter. Warmer will be lighter. Colder will be heavier. So when it is cold, so if environment is colder, then it is heavier. When the pollution parcel is warmer, that means hot, it is lighter. So warmer means lighter, cold means heavier. Okay. So that means at every altitude, if the environment is cooler and the air parcel is the pollution parcel is warmer, obviously this is lighter one, it will move up. And at this level again, at this level also this pollution parcel will have a adjacent environment. Again they both will compare. So here also environment is cooler, this is warmer, it will go up to the next level. Again here also they will compare. Here also the pollution parcel is warmer and environment is lighter, it will move up because it is lighter. So likewise, that means when at every stage, at every altitude, if the environment is cooler and this pollution parcel is warmer, then pollution parcel can safely escape the troposphere. But reverse, for at some position, at the exit point itself, environment is warmer, the pollution parcel is cooler. Then what happens? Obviously environment will move up, this pollution parcel will stay here only. So or it may move down because it is heavier, so it may move down also into the residential areas. So that is what is the concept here. So always for safely disposing or dispersing, here we do two things. We are diluting this into the atmosphere, we are diluting the pollutant into the atmosphere and we are dispersing it. Dispersing means we are spreading it. So we are doing dispersion as well as dilution, both the things we are doing. But as far as air pollutants are concerned, dilution and dispersion are not considered as removal of air pollutant, because when it is dilution and dispersion in disposal of sewage effluent, there the effluent is getting oxidized and they are getting stabilized. But here these pollutants are not oxidized, they are just dispersed into the environment. That means the concentration has reduced, but still it is a pollutant only. Still it is a pollutant only. The effect may reduce. Earlier, if you take that pollution parcel at a point, the effect may be very high. Now the effect may get reduced a little bit, but we cannot say that the pollutant is removed from the atmosphere if it is dispersed and diluted in the nature. Still it is present in the nature, but with less concentration. So for doing that, we need a stack and we need proper environment support, and we need to see the environmental lapse rate. Accordingly, we need to release the pollution into the environment. If we know the environmental lapse rate is not supporting the pollutant disposal, then we need to stop the pollutant. By other means we need to dispose it, okay, whenever there is favorable conditions are prevailing. Okay, so that is what is the concept here. This lapse rate, environment lapse rate, adiabatic lapse rate, they completely deal with how to dispose and disperse the pollutant safely into the environment without affecting the human and plant life and any kind of other things which are associated with that. Okay, so that is what is nothing but this lapse rate. So environmental lapse rate means the change in temperature, of environment with altitude at a given point of time. at a given point of time and at a given place. At a given place. So this may vary. This is not constant. This may vary. Next is adiabatic lapse rate. So the change in temperature of pollution parcel with altitude, same at a given place and at a given time. So this is actually constant. So this adiabatic lapse rate ALR is constant and it is equal to 9.2 degrees centigrade per every kilometer. For every kilometer there will be a lapse of 9.2 degrees centigrade. So 9.8 degrees centigrade. Approximately we can say 9.8 is 10 for 1000 meters. So 1 degree centigrade for every 100 meter approximately. This is an approximation. So always the air parcel temperature reduces or minus 9.8. So 9.8 degrees reduces. So ALR is always constant. Okay. So at every place, at every time the ALR is constant, which is equal to 9.8 degrees centigrade. So but ELR changes with the radiation, daytime, nighttime, winter, summer. So likewise the ELR may changes with time to time, period to period, place to place and season to season, daily also. So there is some, by establishing a relationship between ELR and ALR, we classify the lapse rate as subadiabatic lapse rate and superadiabatic lapse rate and a neutral lapse rate or adiabatic lapse rate. Superadiabatic superadiabatic lapse rate. Superadiabatic lapse rate is nothing but when ELR is, when environmental lapse is greater than ALR, is greater than ALR. Environmental lapse is greater than ALR. That means, for example, at some zero altitude, so environment is with 40 degree and pollution parcel is also at 40 degree. So after 1 kilometer, the lapse in the environment is 10 degrees, okay, or 15 degrees. So environmental lapse rate is more than ALR. It is 10, it is constant. Now environment lapse rate is 15. So that means 40 will become 35 degree at 1 kilometer. At 1 kilometer, this is 10 degree only, so it is becoming 30. Sorry, this is 25. It is becoming 25 degree and this is becoming 30 degree. Who is warmer here? So pollution parcel is warmer. Pollution parcel is warmer, so it will go up to the second kilometer. At the second kilometer, this is becoming 25 minus 10, 15. So it is becoming 10. So it is becoming 20 degrees. So which one is warmer now? At the 2 kilometer altitude, this is warmer. Again it will go up. So wherever you see the pollution parcel is rising up and rising up. So that means the pollution parcel is escaping from the environment. So this is called super adiabatic lapse rate. Super adiabatic lapse rate. Here we call this as unstable environment. So we call this as unstable environment. Here, when the super adiabatic lapse rate is taking place, we consider that the environment is unstable. So which favors the pollution disposal, so we want unstable condition only, so that the pollution parcel will escape. If it is a stable condition, then it will not escape. If it is stable condition, it will not escape. If you see subadiabatic lapse rate, subadiabatic lapse rate, so where ELR is less than ALR. So simply we can understand it now. The reverse phenomena. This will become warmer, this will become cooler. So this will go up, this will settle down. So this is called subadiabatic lapse rate. So if you look at the graphs of this graphical representation, so the lapse rate, so ELR, so this is temperature, this is altitude. So the ELR, so when this is super adiabatic lapse rate, when it is super adiabatic lapse rate, then here see, for the same altitude, this is for the same altitude. So this is cooler, this is warmer. So this is adiabatic lapse rate and this is environmental lapse rate. So if the graph is like this, if the graph is given like this, then it is called super adiabatic lapse rate. If the same graph is given like this, this is ALR, this is ELR, then it is called subadiabatic lapse rate. This is called subadiabatic, this is called super adiabatic lapse rate. So neutral lapse rate, so this is called stable condition. Here we call this environment is stable. So which we don't want. Actually, this is not a favorable condition. This is not a favorable condition for the dispersion and disposal of the air pollutant. So we are exceeding the time. So let me conclude this here. We will discuss the rest of the part in the next session. Thank you so much.